Bon bah écoutez, bonjour à tous. Ah oui, c'est vrai. Hello everyone and welcome to our presentation. We are the group Vaincre les déchets because we are presenting our project which is called Splean. And why Splean? Because it's a contraption between clean and space, because the objective of our project is to clean the orbits of Earth. I'm sorry, I run to come here. So why is it an important project? Because as you may know, there are currently close to 779,000 debris on orbits used by humans around Earth that are more than 1 centimeter in diameter. And the problem is, at that size, those debris becomes dangerous for space missions, for spatial station and other satellites, that are used for telecommunication, for example, and becomes dangerous for astronauts who live in those stations, etc. It can also be dangerous for the environment because of an effect called the Kessler phenomenon. This phenomenon is, to explicit it to you, it's the acceleration of those debris when they hit each other, and they become very dangerous object that goes very high velocity, and when they hit something, they can do very much damage. And the thing is, those materials that are debris, they are made of very rare materials that we find on Earth, notably metals and other rare materials that we can find. So our solution for that would be to have what we would call garbage truck of space. What are those? Those are satellites, and we want to be specialized in designing and deploying those satellites whose missions would be to first surveil those orbits, to detect any object that could be threats, or even to detect objects that can be very interesting for us, for example, that are made of very rare materials. And once those debris are detected, they are then collected by the satellite that store them, and then they can return back to Earth for us to recycle those items, because, as I said, those are very rare materials, and we don't have them in infinite amount on Earth. So we need a way to retrieve them from space. We can't just, because there are other projects, as you will see, that just take those debris or destroy them or just make them flew away in space. But we need to retrieve them to retrieve the materials. And why we do think that this is a very multidisciplinary features, why this project is multidisciplinary, because first, the major components of our satellite would be embedded electronic systems and computer programs to run those. So we can call the LX and the SI to help us develop them. Then we would collect data to know if those features would be successful, and just because we need data to know if something goes wrong or right. So we can call the MEM sector in Polytech to help us with that. And in other less important fashion, I would say, we can call the GE, who would be useful to manage any fluids, because in satellites we do have some fluids like fuel. We also have fluids in mechanical parts that will retrieve those debris. So we can call them to have an expertise on fluids. And we can also call the BAT sector of Polytech to help us with the material expertise. Because as you may know, there is a lot of constraints when you go really high up in the orbits of Earth. So we need someone to be very specific and very expert on materials, and also on project management, because they are the ones that do the most projects and the most management of projects.
As you can see, and as Benoit said, there are several programs that already exist. This program aims to destroy the debris and move them outside the Earth orbit. So we can quote NASA or ESA. So the main goal of this program is just to move and make the debris outside of Earth's orbit so that they can no longer pose a threat to our satellites or new satellites. And in contrast, the goal of our projects is more recycling this debris so that we can recover raw materials that are in limited quantity on Earth.
Now here is our SWOT diagram. I'm just going to say a few words on this diagram. First of all, I want to talk about the technical and theoretical complexity of our project, which is mainly due to the device which is going to be used to send back the debris on Earth, which is very difficult to create and to prepare. And also about the regulatory uncertainty, because on Earth we do not have any real law which is accepted by all the countries in the world. And we have also problems regarding the property of the space debris in general, who is going to pay, etc.
So now that we have presented our company and our product, let's talk about the business model. So there is our Canva business model, but I will talk about just some key points that I think is the more important. So like we said, we propose a space cleaning service. So it's a B2B service, professional to professional, to different clients like spatial, international or national spatial company, or operators company, or telecommunication spatial company. Our revenue mainly comes from the contract and the partnership that we will pass with our customers. We have two kinds of contract: long-term contract and mission contract, depending to the size and the time of the project of our client, so the needs. And to ensure our success, we need to make a lot of investment. The main is the research and the development to improve our satellite technology, production method and recycle method. And we need to not forget the communication and the marketing part to be sure to be able to promote our company and make more sensibilization about the orbital saturation issue.
Now I'm going to say a few words on our Gantt diagram. First of all, our project is divided between 8 major phases. Each of them is associated to 1 or 2 members of the team depending on our skills. And as my colleague said during the presentation, we also have some milestones which are shown in red and white on the diagram. Each of them is associated to a go and no-go statement. The white ones are mainly related to money, and the red ones are more related to technical aspects. The most important ones are probably linked to the patent we want to create to protect our innovation, mainly.
And to finish, we will present you our KPI. So there is a lot of KPI, but I will talk about the 2 most important for us. So the first one is fundraising. We will think that it's accomplished when we will achieve 50% of the budget in research and development, 75% of the budget in the design, and 100% in the tests. And the second KPI, most important for us, is testing and validation stage, which will be succeed if we validate the result of the test in lab, so that we can launch the mission in a low orbit, at the low Earth orbit. Thank you for your attention.
Yes, me. Can you please give several examples of materials that you would like to recycle?
Yeah, so mainly it would be because there is a lot of gold plating that could be used So mainly gold, because there is a lot of gold plating done on the revetment of the satellites, but also very rare like cobalt or even some diamonds that can be used on circuits, for example. There is a lot of materials that can be think of. I don't have the whole list because this was not the goal of the presentation to know what to expect from this. But as we can also know, there is a lot of materials that are mainly considered less rare, like inox or maybe just raw metal that is not in the most rare materials that we can find on Earth, but this must be recycled at some point because we can't have an infinite amount of steel, for example.
Okay. I mean, the critics is that even if you will recycle several tons of gold, the price you can take from this recycling will be just absolutely neglectable with respect to the price of the...
The goal is not to make money off recycling. Yeah. The thing is to recycle them because we needed them for other missions. So it will be a part to return those materials to industries that could use it. So it will be a neglecting part. How we would gain money would be on the contracts, as said my colleague, on the contract made by those companies, because those companies need a way to get rid of those debris, because they can't launch any more satellites, for example. I know for telecommunication, for example, it begins to have some mission needed to be done, because when a satellite dies, it got sent to another orbit of Earth that is called a graveyard orbit. But the problem is those graveyard orbits begins to be filled with materials, and it can be very problematic for other missions. So they need to have a solution for that. So even if recycling materials is not the main part of it, they will need a solution, and I think recycling those materials would be a great way for them to advocate for their cause, a great way to make the world I don't know how to say that, but for their communication, for example, because they can say that yes, they do something for the environment, even though they are still launching things to space that are consuming a lot of fuel, etc. So this is more for them than for us.
Okay, thank you.
I didn't understand how are you going to bring back the recycling materials?
So that's the main part that we are concerned about, because we know that there are some things done that are thought about. You know, I think you've all saw SpaceX retrieve launchers from space. We want to use the same kind of technology, but the thing is, we also need to have reflection on the fact that those satellites are not sent the same way those rockets are sent. So we need to think about that. But the thing is, we have solutions for that, which would be to have mainly the same way, but it could be a lot of different techniques that we could use. We don't think of one particular technique because this would be the part of R&D of the project that was not very asked for, but we thought about it, of course. But we make reserves on if this project is possible or not. This was one of the main weakness of our project, is that we don't know if it is possible. This is why one of our key points on the project is to validate the results of what we have done, because this would be the hardest part of the project, actually. Thank you very much.